I want to introduce you something I'm working on, and which tools that could be really interesting for fighting against the pandemic, by letting us getting a view of what is happening in terms of pandemic progression, and that's in a worldwide perspective. So it means being able to detect new place where the pandemic is starting, place where it is growing, and have a good view of the quantity of people touched by a pandemic in different zones. So to make it happen, I'm through about a product that could be interesting in my point of view, a sensor to detect the pandemic activity. And I want this sensor to be really low cost and easy to deploy, easy to use, to have a mass effect on gathering data for this. And this tool is a thermometer. So this is not a thermometer I've produced. It's a thermometer you can buy everywhere. It's really a standard thermometer. It's something that costs to produce, I think, something like $2, something like this. I buy it, I bought it on Amazon, and I get it for less than 10 euro delivered at home. Okay, so you see it's a really low cost product. And to that really low cost product, I want to addition another really low cost product. It's that product. It's a product I make. So just to introduce me a bit, I'm Paul. I'm a hacker, I'm a device maker, I'm a computer scientist, and I'm an expert of Sigfox technology and an expert of the ultra low cost technology working on Sigfox. So this device is a stick tracker. It's a tracker, basically. But to be more simple, it's a transmitter able to communicate over the Sigfox network. And the production cost of a such device with only what we need for thermometer could be under $1. So my idea is to couple those two devices to make this standard thermometer a connected thermometer for a price of production under $5. So the objective is to have the ability to have a connected thermometer for quite the same price for the final user than a standard thermometer. So this is possible to make, and this is what I will demonstrate in that video with that device. Okay, it's not yet beautiful. It's a prototype. Okay, so it's really like I say, I want to join these two devices in a single device to make this thermometer a connected thermometer. Let's make a demo of it. So here we have our connected thermometer. I have 2 glasses of water. One has a water temperature around the body normal temperature. So it's a bit under now, but I mean, we are at a low temperature level. So it's not overheating, it's just a normal. And in this case, basically, the thermometer is working exactly like a non-connected thermometer. So there is nothing special that is happening. We have the temperature which is measured, and we have some beeps that are indicating that the temperature has been gathered. So now what is interesting is what is happening when the body temperature is over the normal temperature. So we are going to capture again the temperature. This time you see that it's high, so it's over the normal temperature. And so it's going to be detected, and we can have a different behavior. So you understand that the sound is a bit different, and we may see on the thermometer a LED blinking. So this LED is indicating that we have detected the over temperature indicated by the thermometer, and the LED is indicating a transmission over the Sigfox network to report this information. Now the system will start the communication to Sigfox, and we are going to see on Sigfox the reporting of this overheat temperature. So we got it, but we also got it in our application. So here is the message we received for the application. And the second information, which is the localization, is going to be obtained also in a few seconds. So now we got it. And what is interesting is that we can see that on a screen. So here, for example, the position reported for the temperature sensor is that one. It's in my city. What is interesting is that the place where I really live is not that one. I'm really living in this area. So you see that the position is quite good. I'm on the north of my city, but it's not precise, and it cannot let anyone be able to identify that I'm the owner of this overheat temperature. This device is reporting two information. The first one is that there has been a higher over temperature detected with it, which means that if nothing special has to be reported, that the thermometer detects a normal temperature, no communication will be made, no information will be reported. So in terms of privacy, that's quite interesting. The second information that the device is reporting is the location. So it means that we know the quantity of over temperature measured, but also a location. So that's quite interesting when we are looking to a pandemic and want to see the progress of the pandemic and so on. But what is really, really interesting in this is that the position of the thermometer is not precise. When I mean not precise, it's not precise and adaptive by design. That's really, really cool for this and for privacy. What I mean is when we are in a big city with a dense network, we are able to get a precision around half a kilometer or half a mile, something like this. And in such area, in such space, you're gonna have thousands of people. So there's no way to make a link between this thermometer and the ones that use it. And when we are in a non-dense area, where sometimes you can have only one people living in half a kilometer around, in such area, the density of the network is also really lower. It means that the precision of the localization is more something like 10 kilometers to 60 kilometers. So in such situation, you also have hundreds of people to be sure that we cannot trace who has over temperature. So this solution is really interesting because it provides a really good level of information, as the precision, even if it's some kilometers, is really interesting in terms of density of progression of the pandemic and so on. But in the same time, it also protects the privacy of every people, which is, in my point of view, something really important. I really thank you for your time listening to my presentation of this ID and this device. If you are interested in getting more technical details on it, there is a lot of content about that project on my website, which is www.disk91.com, disk91. You can also contact me and ask a technical question. I will be really happy for answering you. And I hope that, like me, you agree that this could be a really interesting thing to fight against the pandemic and next pandemics.